Good morning or good evening. It's good morning for me, probably good evening for you. Today we are going to do Pre-Calc Lesson 32, inverse functions for quadrant signs and inverse trig functions. Let's talk about inverse functions first. Okay, inverse functions. A function only has an inverse if it is one-to-one. So one-to-one functions have inverses, and the graph of a function and its inverse are reflected across the line y equals x. Okay, so every time you have an inverse, right, this is our x, y, this is the line y equals x, your inverse is flipped across this sign. We'll show you examples of that. And how to find it, you switch x and y, and then you solve for y. So let's do examples. Example 1, find the inverse of y equals 2x plus 3. So we switch our x and our y. So I'm going to have x equals 2y plus 3. And then I'm going to solve this for y. So I'm going to subtract 3 from both sides. So I get 2y is x minus 3. Divide everything by 2. So I get y is 1/2 x minus 3/2. That's my inverse. Okay, now let me show this to you graphically. This is x, this is y. This first graph has a y-intercept at 3, and it has a slope of 2. So I'm going to go up 2 over 1, or down 2 over 1. Down 1, 2. There we go. So this is y equals 2x plus 3. Okay, this is my line y equals x. And here I'll graph this line, my inverse. My y-intercept I have is -3/2 or -1.5. And then my slope, I go up 1 over 2 or down 1 over 2. And well, let's see if I can draw this. Alright, so it wasn't a very pretty picture. Should have brought my straight edge. But if you want a really nice picture, go to example 32:1. The graphs will cross and they reflect. I'm sorry guys that my pictures are not very good. Let's do another example. I'm not going to graph the next one. Maybe you have a better graph in your notes. Example 2. Find the inverse of y is -2x plus 5. So again, we swap our x and our y. So we get x is -2y plus 5. And I'm going to solve this for y. So I'm going to add 2y. So I get 2y plus x equals 5. Subtract x. So 2y is 5 minus x. And divide everything by 2. Giving me that y is -1/2 x plus 5/2. That is my inverse. No matter what kind of function you have, if it is one-to-one, which we should know how to find a one-to-one function, then you can find its inverse. Now let's move on and talk about the 4 quadrant signs. We talked about this last year. This is a review. All students take calculus. The A stands for all, meaning sine is positive, cosine is positive, and tangent is positive. We will do a lot more with tangent. Okay. Over here, the S stands for sine, so sine is positive, cosine is negative, tangent is negative. Here, the T is for tangent, so sine is negative, cosine is negative, tangent is positive. And here, the C is for cosine, so sine is negative, cosine is positive, and tangent is negative. You do need to know these, okay? It will change everything if you don't know this. Now, inverse trig functions, okay, we have a domain and range for our trig functions. So the domain for cosine, sine, and tangent, the domain is all angles. Okay, the range for cosine, sine, and tangent is -1 to 1, inclusive, meaning we can get -1, we can get 1. Okay, and what happens in here is when we do our inverse trig functions, we have to restrict the range. So inverse functions have a restricted range because that's what allows it to be 1 to 1. Right? We have to restrict our range and domain here so that I can be 1 to 1 so that I can have an inverse function. Now, we're going to draw an important chart. So here we have notation, restricted range, quadrant. I'm going to put positive quadrant, negative quadrant, and let's draw this across. All right, so our first one is inverse cosine. Then we have inverse sine and inverse tangent. All of the stuff on this chart you will have to memorize. So inverse cosine, our notation, we can write it as arc cosine or cosine to the -1. Inverse sine we write as arc sine or sine to the -1. Inverse tangent is arc tangent or tangent to the -1. Now, the restricted range is really, really, really important, and I'll show you why. The restricted range for cosine is 0 to 180. Sine is -90 to 90, and tangent, inverse tangent, is -90 to 90. Okay? They are all three positive in the first quadrant, and cosine is negative in the second, inverse sine is negative in the fourth, and inverse tangent is negative in the fourth. Okay? Now, some review. We use these functions, inverse cosine, inverse sine, and inverse tangent, to find angles, right? We could have something where we have this triangle and we have theta, √3, 1, and 2, and we want to find theta, we would use the inverse sine, cosine, or tangent to find an angle. Okay? So now let me jump into some examples. That's exactly what we will do. We want to evaluate the arc sine of √2/2. What this is telling me is that the sine of some angle is √2/2. Now, here, I've drawn my 30, 60, 90 triangle. I'm going to also draw my 45, 45, 90 triangle. Because I know that if I take the sine of 45, it's 1 over root 2, which is root 2 over 2. Okay, so the arc sine of root 2 over 2 is 45. Now, here's where the restricted ranges come into motion. We know, all students take calculus, we know that sine is positive in both of these quadrants. So we have this angle here, 45, and we want to get this angle here, which all the way over is 135. However, inverse sine is from negative 90 to 90. That does not include this half. Negative 90 to 90, this is negative 90, this is 90. We are only on this half of essentially our unit circle. Okay? So we do not include this half because it's not in the range of inverse sine. Okay? Really, really, really important that you are aware of the range. Let's do another example. Okay, we want to find the arc tangent of negative root 3 over 3. Now, again, this one I know. I'm going to use my 30, 60, 90 triangle. Okay, ignore the negative for a second. Okay, we know that the tangent of some angle, right, we're looking for to be root 3 over 3. Now, I know that if I take the tangent of 30, I get opposite over adjacent, and if I rationalize that, I get root 3 over 3. So we want to say that we have the arc tangent of positive root 3 over 3 is 30. Now, here's the catch. We have a negative here. Okay? Inverse tangent is from negative 90 to 90, and we know, all students take calculus, that the inverse tangent, the arc tangent, is negative in the fourth quadrant and positive in the first quadrant. Which means if we're looking for negative root 3 over 3, we need to be in this quadrant over here. Okay? We are looking for one that is in the fourth quadrant. So, we would say that the arc tangent of negative root 3 over 3 is this angle right here, which we could say is negative 30. Why wouldn't we say that it was 330? Because we know that if we are going all the way around the circle, this would give us the same answer. The reason we don't say 330 is it is not in our range. It has to be from negative 90 to 90. 330 is not in that. Negative 30 is. Okay? All right, let's do a harder example. We're going to take the cosine of the arc tangent of negative 3 over 5. Okay, this is obviously not one of our special triangles. So, what we're going to do, ignore the negative. We're going to draw a triangle, and I'm going to say this is my angle, right? So, the arc tangent, we're ignoring the negative, of 3 over 5 equals some theta, which tells me that the tangent of that theta is 3 over 5. We know that tangent is opposite over adjacent, so tangent of theta is 3 over 5. Now, I need to find my hypotenuse. I can use the Pythagorean theorem. 3 squared plus 5 squared gives me h squared. So 9 plus 25 gives me h squared, leaving me with 34 is h squared. So h is the square root of 34. And we are just going to leave it like that. Okay? So this is the square root, 34. Okay, now let's look at cosine. So we're now saying that the arctangent of 3 over 5 is theta. I can substitute that in here. So this now becomes the cosine of that theta. Cosine of this theta gives me adjacent over hypotenuse, which is 5 over root 34, which I'm going to rationalize by multiplying by the denominator. Gives me 5 root 34 over 34. Now the negative comes into play. Okay? We know that if the arctangent is negative, we are in the fourth quadrant. This is our theta, right? Arctangent is negative. We want to know, in the fourth quadrant, what is cosine? All students take calculus. Cosine is positive in the fourth quadrant. Therefore, this answer is positive. I don't have to change it. I don't have to add a negative. Okay? All right, let's do another example. Okay, we are going to do the sine of arc cosine of 2 over 3. Okay, again, 2 over 3. It's not one of our triangles, so I need to draw it. So this is going to be my theta. Now cosine gives me adjacent over hypotenuse. Okay? So I need to find this other leg, so I'm going to say x squared plus 2 squared is 3 squared. So x squared is 9 minus 4, which is 5. So x is the square root of 5, giving me the square root of 5 here. Okay, so the arc cosine of 2 over 3 gives me some theta. I'm going to plug that theta in here. So I now have the sine of that theta. The sine of that theta, sine is opposite over hypotenuse, so it gives me root 5 over 3. Okay, and now we have to look at, is it positive or negative? Now we know that inverse cosine is from 0 to 180, so we're up here. Well, everywhere up here, sine is positive. Right? Sine is positive in both the first and the second quadrants, therefore our answer is positive. Okay? We'll do a lot more practice with this when we get to class tomorrow, but for now, that is all. Have a good rest of your evening.